Good morning, students. Next topic is kinematics. In this kinematics, there are two parts: motion in one dimension, that means straight line path, straight line motion, and two dimensions. First we are discussing the first one dimensional and then two dimensional under the same topic name, kinematics. Kinematics is a branch of physics which deals with the motion of objects without mentioning mass and force. These two not mentioned. Without mentioning the mass of the object and the cause of motion. The cause of motion is due to the external force acting. That external force mentioned is not there. A mass means inertia mentioning is not there in the topic kinematics. It is a branch of physics. Kinematics is a branch of physics which deals with the motion of the object without mentioning the inertia means mass and cause of motion means force. In one dimensional motion, object travels in a straight line path, rectilinear motion without a deviation to the sideways. Are just going in the straight line path, that is our rectilinear motion, which is called as, that is related to the one dimensional motion. In two dimensional motions, object is moving such that two coordinates among the three coordinates, x, y, z coordinates, so any two coordinates change, it's called as a two dimensional motion. Changes with time, of course. And in the frame of reference deals with the x, y, z coordinate system called as the Cartesian coordinate system or rectangular coordinate system, and clock. Clock is to measure the time. Clock plus this x, y coordinate system, imaginary coordinate system is actually, that together is called as a frame of reference or reference frame. And in this x, y, z coordinates is one coordinate change with the time, we call it as a one dimensional motion, or two coordinates change with the time is called two dimensional motion, three coordinates change with the time is called as a three dimensional motion. Next, we are going to discuss the equations of motion, kinematic equations of motion. They are called as, for these equations of motion, acceleration should be constant. The final velocity after time t seconds is v equal to u plus at. What is a? A is acceleration. A is nothing but equal to final velocity minus initial velocity by time. Change in velocity by time is called as a acceleration. If velocity is constant, u equal to v, v is the final velocity, u is initial velocity. If v equal to u means acceleration is 0. When velocity is constant, acceleration is 0. If the acceleration is positive, then velocity increases with the time. V is greater than u. If acceleration is negative, called as retardation or deceleration, and acceleration is negative, v decreases with the time. That means v is less than u, a becomes a minus. The sign convention also there for this acceleration, velocities and displacements, called as a Cartesian sign convention in two dimensional motion. If you take a right side motion or one dimension also, one right side motion or velocities, acceleration, displacement, all vectors which can be mentioned with the arrow marks. No? The right side motions directions are positive, left side directions are negative, upward directions, if you are throwing the object upwards, the velocity upwards and displacement upwards, they are all positive. But acceleration due to gravity, moving under the gravity, if the object is moving under the gravity, falling object, vertical projected objects, the acceleration is minus g. You have to take minus means downward directions. Acceleration due to gravity always acting downwards. So wherever a is there, you can replace in this equation, replace with minus g for the objects moving under the gravitational force of these planets, earth or anything. And g mon equal to g earth by 6. Next, final velocity formula v equal to u plus at. And displacement after time t seconds is s equal to ut plus half at square. And final velocity square equal to initial velocity square plus 2as. Displacement in nth second, this is a displacement in t seconds. This is in t seconds. Can be called as n seconds. N seconds is different from nth seconds. This is related to nth seconds. If the object is starting from beginning and this is going to be the first 1 second is called as the first second. Next 1 second is called as the second second. Next 1 second is called as the third second. But total time from the beginning, if you have taken, this is going to be 1 second. This total time is going to be 1 plus 1 is 2 seconds, and this whole total being equal to 3 seconds. After 2 seconds, third second starts. First second, second and third second are only 1 seconds. But when object is under acceleration, due to the acceleration, velocity increases with time. First displacement covered in the first second is less than that next 2 seconds, next second distance covered. So second distance is more than that of the first one. Similarly, third second distance is more than that of the second ones and first ones. As the time passes, the displacement covered increases in 1 second only. Right side of this equation has the velocities. This n is the time. So acceleration time is velocity. These are the dimensions of the time velocity you have. Velocity added to velocity. So left side is not displacement, is actually velocity only. Displacement the nth second way to take. Nth second means actually it is 1 second. Displacement in that nth second is 1 second. One we don't write it generally, but it is a displacement in nth second. That is a 1 second is having the dimensions of velocity. Careful with that word. Next, We can also take the relationship V average equal to U, sum of the two velocities by 2, U plus V by 2, average velocity you can take the condition is that acceleration should be constant, then only you can take this relation. Similar displacement, we can also write this average velocity into time. Next, average speed, average velocity. If you take a speed, if you take the speed, average speed is nothing but equal to total distance by total time you have to take. Total distance by total time. Distance is a scalar, and distance is nothing but length of the path. If the object is traveling from A to B, the length of the path is called as a distance, and the shortest distance from A to B is called as a displacement. If the object is moving a straight line path only, then displacement is equals to distance. Both are equivalent when the object is moving in a straight line path. Otherwise, distance is more than the displacement. Next, object coming back to start, the shortest distance is the displacement we are taking. If the object comes back to starting point going backwards, like displacement goes on decreasing. If the object returns to starting point, displacement is 0. But the distance is not 0, total distance you need to consider. So average speed equal to total distance by total time. This is speed. Similarly, if you take the average velocity, if you take the velocity V average equal to total displacement by total time we have to take. If the object come back to starting point, total displacement is 0, then average velocity is 0, but average speed is not a 0. In case if the object is moving in a circular path, in these cases distance is greater than or equal to displacement. When is the displacement equal means equal to distance? When the object is moving in a straight line path only, both are equals. If the object is moving in a circular path, A came back to starting point, means B is there only, then the total distance is nothing but equal to 2 pi r it becomes. R is the radius, but the displacement is the shortest distance, which is going to be 0. Next, if the object moving in a semicircular path only, A to B, then the displacement is diameter, shortest distance is diameter, displacement 2r it becomes. Displacement is 2r and the distance is the circumlength, half of the circumlength, which is nothing but equal to pi r it becomes. And this time where speed, average speed etc. given means this by time. Distance by time or displacement time you need to consider. In these equations, if the object start from beginning case, beginning condition starting point means t equal to 0 you have to take in expressions. If the object start from rest, u equal to 0. If object is coming to rest, final velocity v equal to 0. When time t equal to 0, if the object is not starting from origin, already it is some distance from origin, then wherever s is there, you have to replace with s minus s naught. Most of the problem they don't give you in terms of the s naught. If the object is starting from the origin only, then s naught equal to 0. Next, relative velocities. The velocity of one object with respect to other object is called the relative velocities. The relative velocity is equals to difference of the final velocity minus initial velocity in terms of the vector notation. But magnitude terms, if you have taken in one dimensional motion, the velocity in one direction, objects moving in the same direction. Same direction means relative velocity is difference of the two velocities. And similarly for acceleration also, difference of two accelerations. Opposite directions they are moving the velocity, relative velocity, sum of the two velocities of the two objects, and acceleration also sum of the two accelerations. Same direction and opposite direction addition, same direction subtraction. If the initial separation of the two objects are moving in one direction, two vehicles we can say, velocity v1 and v2, and separation is s. This v1 is greater than v2, then after some time this v1 is overtake v2. Then after what time they are going to meet, the initial displacement s equal to ut plus half at square, but u take as u relative, a take it as a relative. If they are moving in the opposite direction also, same relation you have to take a initial displacement, after time t second they are going to meet. This expression you have to take, same direction, difference of the velocities and accelerations, opposite direction addition you have to take. And if there is no acceleration, then a equal to 0, means velocity is constant. And in the case of the objects moving under the gravity, wherever the a is there, you have to take it as equals to minus g, gravity motions. And if the free fall, if you have mentioned free fall means initial velocity u equal to 0, dropping object, free fall u equal to 0. In these expressions you can take the object which is projected upward directions. When you are throwing it up, after what time it reaches the maximum height, whenever it reaches the maximum height from the ground, displacement is upward directions, positive you have to take and final velocity at the highest point becomes equal to 0. Initial velocity u is upward, so positive. In this sign convention you take for these expressions, and s wherever is there you have to replace with the h. and time of ascent, time taken to maximum height is nothing but equal to u by g. Same time it take to touch the ground if there is no air resistance. And h maximum is nothing but equal to u square by 2g. H maximum will get minus, don't take this minus and just know the downward direction if I am mentioning it. Next, total time of flight, time of equal time of descent. So time of flight is nothing but equal time of ascent plus time of descent, which is equals to 2u by g. These are the equations we take for the object which is projected upwards and again coming back downward directions. If h is displacement travel is positive, final velocity v equal to u plus at. You are taking u plus at. U is initial velocity positive, but g, a replaced with minus gt. If v is positive, object is still going upwards. V is 0 at highest point. If v becomes equal to minus in the expression, that means it went up and again coming downwards. Whenever it comes to the ground and at any point height, the upward velocity equal downward velocity, only direction is reversed. Next, if the object is dropped from the rising balloons, balloon can be moving upward directions, hot air balloons or even helicopters moving upward directions with acceleration or with uniform velocity, both can possibilities there. And if the balloon is rising up, some stone is dropped from it, the balloon for example moving with uniform velocity u. The stone which is dropped will not fall down immediately downwards, it goes up because the velocity for the stone is upward direction, it goes up and falls downwards onto the ground. The total displacement, initial height of the height of the balloon is h, means the displacement becomes equal to minus h. Same condition you have to take for the stone which is projected upward from the top of the building. From the top of the building, if you are throwing the stone up, building height is h. Throwing up, it goes up and again comes downward, the displacement is minus h. At the reaching highest point, final velocity is 0 at this point. So what is the formula for this is s equal to ut minus half gt square. S becomes equal to minus h, total displacement is minus h equal to minus ut, u is upwards only positive, minus half gt square. You can take h equal to minus ut plus half gt square. T is the time taken to touch the ground. Next, textbook problems from your material. Question number 86. In this question, what they mentioned is one object is moving in a straight line path with a constant acceleration starting from rest. Starting from rest means u is 0, a is constant, and total time of travel is 6 seconds. Acceleration is there means velocity is not constant. So in the first, s1 is the distance traveled in the first second. S1 is the distance covered. S1, S2 and S3. This is the first 2 seconds. This is the next 2 seconds. This is the next 2 seconds. Because of the acceleration, the distance covered will be more. So you are asked to find out. The ratio of S1, S2, S3. Equation is 2 seconds, not second. Therefore, you take s equal to ut plus half at square. U is 0, not required. S equal to half at square. A by 2 is constant, so you can directly take proportional term. S1 is proportional to t square. T is 2 seconds. First case we take is equals to 2 seconds. Then S1 is equals to a by 2 into 2 square means 4 you will get. So this 4 we need. Next, starting from the beginning you have to take from here to here. 2 plus 2 is equals to 4 seconds. So total distance traveled is S1 plus S2. We cannot take that u is 0 for the second only, we should not take, please. You have to take from the beginning, because u is 0 means equation becomes more simple. Otherwise you have to calculate the velocity here, and that you have to take the initial velocity for the S2. That will be more steps you will get. Better take from the beginning only. So our total displacement is S1 plus S2, total time is equal to 2 plus 2. U is 0 now in this case also, because you are taking from the beginning. S1 plus S2 equal to a by 2, u is 0, a by 2 into t square. T is nothing but equal to, total time is now 2 plus 2, 4. 4 square is 16. So S1 plus S2 proportional to 16 we can take. Okay, this equation required later. Next, S2 we want. S2 is nothing but equal to S2 we want. So we take S1 to the other side. S1 is nothing but equal to 4. So 16 minus 4 directly can take for 12. These are the equation. Next, total distance if you take S1, this 2 plus 2 plus 2 is equals to 4, total is 6 seconds. Then S1 plus S2 plus S3 equal to a by 2 into 2 plus 2 square, which is equals to 6 square is 36 you will get. Total is equals to this 36. But we don't want this total distance, we want only S3, means you have to subtract S1 plus S2, this value. You subtract from this, 36 minus 16 is 20. So S3 is equals to, is proportional to 20. Ratio if you take a 4, 12, 20. 4, 12, 20. Divided with 3, we will get 1, 3, 5 is the answer. Next question number 89. In this question, u is 0, initial object starting from rest, and the acceleration is constant. It covers the displacement. We are talking about the displacement only in the problems of equations of this equation of motion. We are talking about displacement, not distance equations, not scalars. So we are all related to vector relation only. Displacement equal to 36 meters in first 2 seconds. Displacement, what you have to find out, 11th second how much. First case is 2 seconds, not second. 2 seconds means s equal to ut plus half at square. S is given as 36 meters and u is 0. So this is 0. Half at square, half a into t square. T is 2 seconds. So we take a t equal to 2 seconds. T equal to 2 seconds means t square is 4. 2 cancels, you will get is 2a. 2a equal to 36. So a equal to 36 by 2 means 18 meter per second square is the acceleration. Next case is in the 11th second displacement. 11th second displacement L equal to 11th second. Then displacement in nth second is Sn equal to u plus a by 2 into 2n minus 1. Here starting from rest u is 0, so Sn equal to a by 2 into 2n minus 1. A already we got as 18. 18 by 2 is 9 into 2n minus 1. Careful with this board mass rule. Don't subtract and multiply please. First multiply and then subtract. 2 into 11 is 22 minus 1 is 21. 21 into 9 is nothing but equal to 189 meters is the displacement travelled in a nth second. Next 90th question. Bullet traveling horizontally loses 1 by 20th of its velocity while passing through a plank. You have to ask to find out how many planks are required to stop the bullet. Bullet loses 1 by 20th of velocity while passing through a plank. Plank means plate. How many planks are required to stop it? Find number of planks required to stop it. So equation of motion we take is v square equal to u square plus 2as term, but here direct formula is there for this. Velocity loss for one plank, if it is passing bullet, initial velocity is u, final velocity is v. Okay, and how many planks, such planks are required? This thickness is equals to s naught, I will take a s, we can take s equal to ut plus v square equal to u square plus 2as. But when passing through this number of planks, this is nothing but equal to, number of planks is nothing but equal to s naught. Each one is s naught into n number of planks is going to be total distance it becomes. And here when coming with the velocity u, final velocity v becomes equal to 0 by the time it reaches to the top end of the plank. So v square equal to u square plus 2s only, but our formula for this is number of planks required to stop the bullet is n equal to n square by 2n minus 1, which is approximately equal to n by 2 plus 1. What is n? N is a fraction loss. N is nothing but equal to fraction of velocity loss. This is nothing but equal to change in velocity by time. V minus u is a difference in velocity, or we can take it as a v1 and v2 also is equals to v u by n, which is given as 1 by 20. Velocity loss, or losing how much velocity? Loss is nothing but difference in velocity is 1 by 20th of the initial velocity. So 1 by 20, 1 by 20 means don't take n equal to 1 by 20, you take n equal to 20 only, denominator only you take it up, n equal to 20, write this expression and you will get the relation. So equal to u by 20, that means what? N equal to 20 you will get. So if you take this relation into this number of planks required, you will get is equals to n square by 2n minus 1. If you substitute this relation for n, 400 square by 20 into 2, 40 minus 1 is 39. You will get a 10 point something you will get. 10 point something it means you cannot cut the plank to thickness, you have to take the complete plank only. 10 point anything, 20 point anything comes means round it to higher number. Or directly can go for this approximate formula n by 2 plus 1. That means this number of planks required equal to n by 2 plus 1 I am taking. N is 20. 20 by 2 plus 1 is equals to 11. 11 planks are required to stop the bullet. If you take this 10 point you will get whatever 10 point anything you take it as a approximately to 11. Higher number only you have to take. Next, a similar problem is 94. Bullet loses half of its velocity. Bullet loses half velocity when traveled 15 centimeters in wooden plank. Wooden block better take, not plank. Plank means very thickness is lesser. Block means large thickness. Wooden block. What is extra distance travelled before coming to rest? Find additional distance or extra distance. It covers before coming to rest or before stops. It is a large wooden block. Bullet is coming with velocity, initial velocity u. After traveling distance equal to x, the velocity is, final velocity is v. It is losing some velocity, which how much is? Half of the initial velocity. But what is the extra distance it travels? This I will take it as a s naught. No. 15 centimeters, no, x. What is the extra distance is nothing but equal to, I will take it as a s. Or we will take it as a s naught. This total distance is s v square equal to u square plus 2ac. When what is v here at the end point is 0. I will take this initial velocity as v1. So acceleration is retardation throughout the metal remains constant. Retardation is nothing but negative acceleration, which is decreasing the velocities of the bullet as it passes inwards. So v1 square minus u square equal to 2ax we can take, and v square minus u square equal to x plus s you have to take. S is the extra distance travelled. The direct formula is there for this. X equal to extra distance or additional distance, s equal to x by n square minus 1. What is n? Is fractional loss. Fractional loss of velocity is v minus u. Here v is less than u, so you can take it as a u minus v also. Previous case also I mentioned it as v minus u. You better take it as a u minus v because final velocity is less than initial velocity. Here also we can take u minus v. E is nothing but equal to u by n. What is this equal to? Is half lost. This is given as u by 2. So n equal to 2 you have to take, don't take half. Careful with that fractions. So this becomes equal to, what is x value? X value is initial points. Initial distance is nothing but equal to 15 centimeters they mentioned. So this is going to be 15 by 2 square minus 1. 15 by 4 minus 1. 4 minus 1 is 3. That means 5 centimeters is the answer. So additional distance it travels is 5 centimeters. This is nothing but equal to 15 centimeters. In the diagram I mentioned it smaller. This is x 15 centimeters. This is s 5 centimeters. V is 0. This is a v1. v1. Next problem, number 97. A car moves from A to B at 20 km per hour. These problems are important for the case at even other exams also. A car moves from A to B at 20 km per hour speed and from B to A at 30 km per hour speed. Find average speed. In this case, constant speed is there. Constant speed in each directions. That means acceleration is 0 we have to take. Then what is the average speed is nothing but equal to total distance by total time. Be careful with this. It is the distance I have taken, not a displacement. Total distance. Coming back, no, when come back to starting point, displacement is 0. Then average velocity if you take, no, displacement means average velocity is 0 when coming back. If you are using average velocity, total displacement, total time. But if it is going straight line path, and instead of turning back to the same starting point, no, A to B and again same distance traveling, same direction traveling, then you can take average speed, average velocity same, then the motion is on a straight line path. Same formula is applicable for average velocity also if the direction is same. Careful with this question please. Average speed is total distance by total time. What is the total distance traveled is while going forward S1, coming back S1. Same distance traveled, so S1 equal to S2. Speed it is. Speed is equals to distance by time. Speed is equals to distance by time. V equal to S by T. V1 equal to S1 by T1. V2 is equals to S2 by T2. But here for us coming back to same starting point, distance is same. S1 equal to S2 equal to S. Then putting the value here, S plus S is equals to 2S. And T1 plus T2. Values are not given for T1. Then what you have to do is you have to eliminate this T1. In these two types of questions, you may have to eliminate displacement in terms of the velocity is given out of these three. You may have to eliminate the time or you may have to eliminate the displacement in terms of the velocities. Here you are given that the same distances, no, S1 plus S equal to 2S, you will get S nothing but equal to V1 T1 and V2 T2. You have to get the expression in terms of velocities and time you have to eliminate. Distance is same, so time you have to eliminate. Time not given in the questions. So T1 is equals to S1 by V1, T2 equal to S2 by V2, means S by V1, S by V2. SS cancel, the result is average speed equal to V1 V2 by V1 plus V2. This is direct formula, you have to remember. 2 V1 V2 by V1 plus V2 is average speed. Average velocity also same formula if it is going the straight line path. If not same distance, no, you have to use that corresponding distance and times. Here in this case V1 is 20 km per hour. V2 is 30 km per hour, A to B, B to A, same distance. So 2 V1 V2, V1 is 20 into V2 is 30 by V1 plus V2 is 20 plus 30 is 50. The result is 24 km per hour. It's not a 20 plus 30 by 2 average, don't take. 20 plus 30 by 2 is 20 plus 30 60, 50. 50 by 2 is 25. 25 you won't get, please 25 or 4 you will get. Careful with this problem. Next, when you can take V1 plus V2 by 2 is with straight line motion with the constant acceleration is there only, we can to take that V1 plus V2 by 2. Next, car moved, second problem 98. Car moved at 20 km per hour in first 5 seconds and 30 km per hour in the next 2 seconds. Sorry, next 2 seconds, I think next 5 seconds. First 5 seconds and next 5 seconds. If the time is different, it means different you have to use, but in this problem given same time. 20 km per hour in first 5 seconds and 30 km per second speed in the next 5 seconds. Find the average speed they asked. So average speed equal to total distance by total time taken, S1 plus S2 by T1 plus T2. In this case we are given the time also, speed also, but distance not given. You have to eliminate distance. What is S1 V1 T1, what is S2 V2 T2. So S1 replaced with V1 T1, S2 replaced with V2 T2 by T1 plus T2. The result is V1 is 20 into T1 5, V2 30 into time is 5 by T1 plus T2, 5 plus 5 is 10. The result is 25 km per hour. Next problem, car moving at 3 meter per second. These problems are very very important, please, repeatedly asked for the case set also and even other examinations. Car moving at 3 meter per second due east, means towards east, 3 meter per second eastwards, and turns, repeated word, and turns north, due north, turns towards north, and time taken to take a turn is 6 seconds. It need not be short turn, not necessary, even if you take the curved turn also, going this side and turn this side. This is north, south, east, west. Diagrams you need to know for these directions, geographical directions. North opposite is south, east opposite is west. We are looking into this, right side, your right side is east, left side is west. Careful with the terms. Next, the object is moving towards north first. Vector diagram you need to take towards north. sorry, towards east. First it is going towards east, then turn towards north. Turn towards north. The degree angle of rotation is nothing but equal to 90 degrees rotation. And we want to find out the acceleration. Acceleration is nothing but equal to change in velocity by time. If you take in terms of the velocity vector terms, vector rotation by 90 degrees, v1 is not equal to v2 in magnitude. Value is same, but direction is not same. So change in direction is also there. Velocity is a vector, direction changes and magnitude changes, acceleration is present. So same speed is same. Find the acceleration. So v1 equal to v2, magnitude you take it means magnitude of the velocity is nothing but speed. v1 v2 value is nothing but equal to, that is v equal to 3 meter per second. Time taken to turn is 6 seconds. Change in velocity equal to delta v is nothing but equal to v2 minus v1, final minus initial. And you have to take the help of the parallelogram law of addition of vectors relationship. Vector a minus b, magnitude is nothing but equal to root of a square plus b square minus 2ab cos theta. If it is a plus b, v square a square plus b square plus 2ab cos theta. Theta is the angle between v1 and v2. What is the angle between v1 and v2 is equals to 90 degrees. Cos 90 is 0. So this cos 90 is 0, but v1 equal to v2 in magnitude. These are all related to the magnitude only. So this is going to become equal to v square plus v square is 2v square under root is equals to root 2 into v is change in velocity. And you are asked to find out the acceleration. What is acceleration equal to? Change in velocity by time. Change in velocity equal to root 2v by t is 6 seconds. T is 6 seconds substitution, v is equal to 3. V is equals to 3 meters per second. So root 2 into 3 by 6. 3 by 6 means by 2. Root 2 by 2 is 1 by root 2. Towards what direction? Because it's a vector, no, direction also very important here. If it is going right and turn, acceleration is in between you have to find out. This is the direction of change in velocity direction is acceleration. What is the change in velocity direction is delta v. That is nothing but equal to v2 minus v1. In vector addition, two vectors are taken in the same order. For the triangle, the resultant is nothing but third side taken in the reverse order is delta v. Delta v magnitude we are taking here. So delta v is root 2v. That is direction of change in velocity, and acceleration is in the direction of change in velocity. So a and b same direction is in this direction. What is the direction now? This is going to be theta. Tan theta is nothing but equal to this opposite side by adjacent side. v1 magnitude by v2 magnitude. So tan theta is nothing but equal to here, because to this theta 90 taken, no, I will take this angle as different symbol, that is alpha I will take. Tan alpha. Tan alpha is nothing but equal to v1 by v2 magnitude. v1 by v2 in magnitude. But v1 equal to v2, that is 3 by 3 magnitude. Means 1. 1 means alpha is equals to 45 degrees. 3 by 3 equal to 1. So alpha is 45 degrees. So this is going to be having the alpha equal to 45 degrees. That means exactly in between north and west, opposite direction, or north and east. Don't take this north and east. It's going this side and turned. In between you'll find that is direction of actually centripetal acceleration also. So in between north and west, this is direction of the resultant acceleration. In between exactly midpoint means it is going to be 45 degrees. This is 45 degrees, and we call this direction as northwest. This direction is called as northwest. So acceleration is 1 by root 2 meter per second square northwest. Here meter per second given means I didn't write the units here, meter per second square. Same units you have to take, and direction is northwest direction. Next, in case if you are given the any angles, what to find the change in velocity formula? v1 and v2. This formula only we have to use and modify it. 1 plus cos theta. 1 minus cos theta you will get term inside when v1 equal to v2 magnitude. 1 minus cos theta is 2 sin square theta by 2 under root. You will get the result of change in velocity magnitude is nothing but equal to 2v sin theta by 2. You have to remember this formula. When theta is given, you can find out what is the change in velocity. Acceleration is nothing but equal to change in velocity by time. This term by t only you have to take. Semicircular path, if you are taking the object moving in a semicircular path, that means it moved from here to here. What is the change in direction of velocity? Theta is nothing but equal to 180 degrees. Opposite direction means 180 degrees. Theta is become equal to 180 degrees. This is going to be 180 by 2 is 90. Sin 90 is 1. 2v by t is going to be the change in velocity. But if you take in terms of the vector notation change in velocity value, what you take is right side velocity, same magnitude, but direction change. This is going to be v. Reverse direction is going to be minus v. Change in velocity becomes equal to minus v, final value minus initial value. Minus v becomes equal to minus 2v. If the object direction is reversed in vector form, if you mention means change in velocity becomes equal to minus 2v. Minus indicates direction place. And in this case only magnitude I mentioned here, magnitude it is. Direction means negative sign comes if it is opposite direction, otherwise negative sign won't come. If they rotated by 90 degrees, what is our term is 90 degrees rotation. 90 means 90 by 2 is 45. 90 by 2 is 40. Sin 45 is 1 by root 2. 1 by 2 by root 2 is going to be 2 by root 2 is going to be root 2. We got this. We're getting this. Okay, that is acceleration. No. So this is going to be root 2, 45 degrees. You will get 1 by root 2, 1 by root 2, 2 by root 2 is root 2 v you will get. But acceleration you have to find out by 6. You will get the same relationship as that before. Next problem is 115. This is for JE mainly. Very rarely ask for the NEET. Please prepare for not for KSET problem. JE problem it is. We are given the time relation as t is equals to x square minus 1 to the power of half, means root may be given here, or they may give like this also, like root with root also symbol may give. You are asked to find out what is the acceleration. You have to take the differentiation of the displacement. Dx by dt is velocity, dv by dt is acceleration. So modify this expression, square both sides, root you can remove, or like that also differentiation you can do and you can calculate. Steps will be different. Squaring both sides, what you get is t square equal to x square minus 1. And differentiate this x square minus 1. I will take this t square to the right side. 1 take it to the left side becomes equal to 1. 1 take it plus 1 becomes take it to the left side. 1 equal to x square minus t square it becomes. 1 is equals to x square minus t square. And differentiate with respect to time. Differentiate with respect to time right for time, and dx by dt, dt by dt it becomes. So what you get the relation is 2x into dx by dt, or 2x into dt minus 2t dt is equals to 0. We can take this also 2x into dx by dt also we can take. By dividing this dt we will get the same relationship. Next you will get this relation is equals to, take it to the right side, 2 cancels, 2x dx equal to 2t dt, 2 cancel it. So x dx equal to t dt you will get. Then what you get is dx by dt we want. Dx by dt is nothing but equal to velocity. X into dx by dt is x into velocity equal to t will have. So differentiation of the displacement of time is dx by dt is v. X into v equal to t. What is v equal to t by x? These equations we require later. Next we want the acceleration, means differential velocity is nothing but equal to acceleration. You can take here or you can take here. So here x and t, v all are variables. So take it as relation is equals to dx by dt. This is a partial differentiation. Partial differentiation, how do you take a partial differentiation? If you are taking the differentiation of two variables you have taken. Differentiation of xy, partial differentiation is nothing but equal to, you take one constant and differentiate the other one, x into dy. If you take differentiation with respect to time by dt means x into dy by dt plus x, first x constant divided by variable. Next what we take is y constant to x variable, means y into dx by dt. This is called the part differentiation or partial differentiation. If you take by dt, then this becomes equal to by dt and by dt. Both sides you can multiply with dt, you will get the expression required, dy by dt and dx by dt in all variables you have taken. That is a partial differentiation, two variables. So if you take this differentiation of this term, this equation 2, I am differentiating, x you will taking constant dv by dt, x into dv by dt, or first to take v constant dx by dt. So dx by dt into v plus x constant dv by dt is equals to dt by dt. Left side what I get here is dx by dt is nothing but equal to v. V into v is v square, it becomes. X into dv by dt is acceleration. So x into a, dt by dt is 1. So v square plus x equal to 1. We want acceleration a. So get the expression for a. X equal to 1 minus v square. A is equals to a. We want expression of x equal to 1 minus v square, which is equals to 1 minus t, this v square. V square expression we can get the relation from here. V is nothing but equal to t by x. V equal to t by x. So v square equal to t square by x square. 1 minus t square by x square. LCM if you take x square minus t square by x square. But x square minus t square is nothing but equal from this equation 1 you will get. X square minus t square is nothing but equal to 1. So 1 by x square. So acceleration is nothing but equal to x. Go to the right side, in the denominator x cube it comes. Acceleration is 1 by x cube. This is multiple times repeated with the similar symbols. Just only modification is root will be changing or square will be terms changing. So you don't have to work out second time. If you remember this, it is a simple problem. Directly you can go for the answer. Say equal to 1 by x cube. Next question number 119. In this case you are given displacement y equal to, symbol may be given x, y, z, whatever it is, or s. 2t square plus t plus 5 meters. SI units are given. Find acceleration at time t equal to 2 seconds. Differentiate this displacement with time, you will get the velocity. If you differentiate velocity with respect to time, you will get the acceleration. So velocity v equal to dy by dt, and differentiation of t square is 2t into 2 minus 1 power. Differentiation of x to the power of n is nothing but equal to n into x to the power of n minus 1. So differentiation of the constant, this is a constant is 0. Differentiation of t means dt by dt, or t to the power of 1 minus 1 is 0, t to the power of 0 is 1 you will get. So directly must be able to write this becomes equal to 2 into 2, 4t it becomes, and differentiation of the t, dt by dt is 1. Differentiation of the constant 5 is 0, this is a constant. Constants cannot be differentiated. So this is the velocity you will get. Sometimes they ask you what is the initial velocity. They ask initial velocity, time t equal to 0 you take it up. Time t equal to 0 you will get initial conditions. Initial time t equal to 0, then velocity is 1 meter per second. Next, after any time t given what is the velocity means you can find out by this method. Next, acceleration. Acceleration is nothing but equal to change in velocity by time. The change in velocity by time, the differentiation of this velocity with respect to time will get the acceleration. So again differentiate this, 4t plus 1. 1 is a constant, differential constant is 0. Differentiation of 4t becomes equal to 4 into dt by dt is 1. So 4 meter per second square is the answer. Next question. Stone is dropped from top of a tower, reaches the ground in 4 seconds. Find the height of the tower. H is equals to ut plus half at square. S is taken as h, but downward direction no, minus h. Minus one sign, careful with that, not necessary every time. So here minus 1 indicates downward direction, and u is 0, dropped they told, dropped free fall means u equal to 0, initial velocity 0, a equal to minus g. A equal to minus g means g is 9.8 if they don't give the value. If whatever the value give, that you have to take. H is equals to u is 0, this part is 0, minus half, a is 9.8 into t square. T is given as for the t equal to 4 seconds they told, no sorry. T is equals to 4 seconds. So this h is equals to 0, half into 9.8. Minus I am not writing because it is downward directions. That means the minus only indicates a downward direction. So h is equals to 0, half 9.8 into t square. Time taken is equals to 4 seconds. T equal to 4. This is going to be t square is 4 into 4. It will be equal to 2 which is equals to 8. 9.8 into 8, which is 78.4 meters is the answer. Minus sign, if you take also no problem, minus indicates only downward direction. So at the result you don't have to mention it because height fall only you are taking. Next. Question 131. Two stones are dropped from height with a successive time interval gap of half second. The time gap may be given different values, but same condition you need to take. Find the relative velocity asked of one with respect to other. First stone dropped. After 0.5 seconds, second stone dropped. So time interval what you are taking, in that 0.5 second already first stone dropped, traveled some distance. So this first stone only taking more time. So the whatever extra time you are taking, that don't add it to the second ones. Second one just starting now only. So for already first one you are taking, for that only you have to add the time. Don't add the second stone for the time gap, time interval. So that is important here. So v equal to u plus ac formula we have to take, but u is 0. U is 0 here. U is 0 because dropped, free fall, and a equal to minus g. So we'll get as minus g. Minus is also not compulsory required here. You can eliminate it. Just gt you can take. Gt. First object is 0.5 extra second comes. Second one is nothing but equal to just gt comes after t seconds. Next, relative velocity is nothing but equal to large minus second. First one has the more velocity than second one. Just take v1 minus v2. And I didn't take the minus sign here. Just neglect it. Both are having downward direction only. So g into first one, gt, g of t plus 0.5 minus gt. So expand the brackets, gt plus 0.5 g. gt into 0.5 g minus gt, plus gt minus gt cancel, result is 0.5 g means half g, means g by 2 is the answer. Next question is 132. Some problems will be given multiple times asked. Just comparison, take with the standard equation and you will get the result. You are given acceleration as the constant and nth second displacement is given as Sn equal to 0.4 n into 9.8. You are asked to find out the initial velocity. You have to take the help of the standard equation for the displacement nth second. Displacement nth second is nothing but equal to u plus a by 2 into 2n minus 1. Displacement nth second is nothing but equal to u plus a by 2 into 2n minus 1. But this expression you have to modify this according to this expression. Or you expand these brackets. U plus a by 2 into 2n becomes equal to 2 cancels. No, an minus a by 2 comes. This an is having the terms n. Here also n term is there. Here u and a by 2. These are the constant terms. So an compare with whatever n is there, no, this part you compare with this 0.4 n an. That means an is supposed to be a into n, it is not subscript n. A into n is equals to 0.4 n. What you get is a equal to 0.4 meter per second square. Same units what is given that you have to take here. Next is second part. This remaining constant u minus a by 2. U minus a by 2 is the remaining portion, that is only 9.8. U minus a by 2 is 9.8, but a is 0.4. 0.4 by 2 is 0.2. Equal to 9.8. U equal to 9.8 plus 0.2 is equals to 10 meter per second. 10 meter per second is the initial velocity.